Welcome back to AI for GIs. I'm Dr. Justin Webb. This is Class 2, the AI Family Tree. Today you'll learn to classify all AI systems and evaluate vendor claims. Here's the problem you face. A vendor just pitched your command on their latest system. The sales presentation promised advanced AI with deep learning and AGI capabilities. Your commander nodded along, impressed by the technical language. The thing is, half of what they said was marketing hype, and the other half was technically impossible. How do you spot vendor BS about AGI without getting lost in technical jargon, even if you have zero AI background? By the end of this class, you'll have 3 complementary frameworks to evaluate any AI claim you encounter. You'll draw the nested hierarchy from memory, distinguish what exists from what's theoretical, and match AI types to problem types. Let's begin. Here's what's happening right now in military procurement rooms across the Department of War. Vendors mix legitimate AI capabilities with marketing hype and impossible claims. Without technical expertise, all claims sound equally plausible. You're a decision maker who needs frameworks to distinguish real from exaggerated capabilities. The current challenge: evaluating technologies that didn't exist in previous procurement cycles. Look at this visual equation. Legitimate AI capabilities plus marketing hype and impossible claims plus lack of technical expertise equals evaluation challenge and uncertainty. This is the problem this class solves. So what are we going to do? We'll use 3 classification systems working together to provide comprehensive evaluation capability. System 1 is the nested hierarchy, organizing AI into a series of nested categories from broad to specific. Think Russian nesting dolls. System 2 is capability levels, distinguishing domain-specific capabilities that exist today from theoretical general intelligence. System 3 is functional branches, categorizing AI by the 12 problem-solving approaches and application domains. Together, these provide vocabulary and mental models for critical AI assessment. 3 complementary systems taught across 3 AI classification systems. McCarthy's 12 AI branches provide the foundation. Let's start with the nested hierarchy. AI technologies fit together like Russian nesting dolls, with each layer representing a subset of the one containing it. The term artificial intelligence has been in use since 1956. It's the broadest category, machines performing tasks requiring human intelligence. Machine learning is a subset, learning patterns from data versus explicit rules. Deep learning uses multi-layered neural networks inspired by biological neurons. Generative AI creates novel content, text, audio, video, imagery, code. LLMs, large language models, are the most specialized, focused specifically on text processing. Understanding this position in hierarchy clarifies capability boundaries. When someone claims their product uses deep learning, you immediately know where that sits. It's a subset of machine learning, which is a subset of AI. Precision in language indicates precision in understanding. Here's how we got here. Some historical context helps clarify this hierarchy. The 1980s were the era of rule-based expert systems dominated by AI applications. Expert domain knowledge was encoded using if-then rules, knowledge engineering, and predefined decision-making logic. This was symbolic AI. The 2000s saw statistical pattern recognition systems become prevalent. Large datasets enabled modern machine learning with data analysis, probabilistic models, and feature extraction. Each layer represents increased sophistication in learning approach. Modern systems often combine multiple hierarchy levels, and understanding position in hierarchy clarifies capability boundaries. Here's the stat that will change how you evaluate every vendor claim. This slide is critical. Pay close attention. 100% of existing AI systems are artificial narrow intelligence, ANI. 0 exceptions. ANI is optimized for specific tasks within defined boundaries. Even world champion defeating systems remain narrow AI. High performance does not equal general intelligence across domains. Artificial General Intelligence, AGI, is theoretical human-level intelligence. 0% exists today. Artificial Superintelligence, ASI, superhuman intelligence, also 0%. This is the current state as of this document writing. Every AI system you have encountered, read about, or will encounter in your military career today is narrow AI. No exceptions exist. Let me emphasize this point about AGI and ASI because vendor marketing exploits confusion here, and that confusion costs the Department of War millions. AGI, Artificial General Intelligence, involves human-level reasoning, effortless transfer between tasks, adaptability to novel scenarios, and self-improvement. This is theoretical. It remains entirely unimplemented. ASI, Artificial Superintelligence, goes beyond AGI to exceed human capability and future state speculation. It's conceptual frameworks in current tech. Current status: no AGI exists. Contrast this with theoretical concepts on the left. Here's the warning for evaluation of AGI claims. Vendor claims of AGI-level capabilities indicate ignorance or deception. Claims of systems that understand like a human should trigger immediate skepticism. High discrepancy between marketing and actuality is common. Learning capabilities are narrow and domain-specific. Now, let's look at the third classification system. This one asks, what problem does the AI solve? John McCarthy, one of AI's founders, identified 12 foundational branches categorized by problems they solve. Logical AI uses formal logic and reasoning. Search handles problem solving through exploration. Pattern recognition identifies regularities. Representation encodes knowledge. Inference derives new conclusions. Common sense reasoning covers everyday knowledge application. Learning extracts patterns through experience. Planning develops sequences of actions. Epistemology determines the nature of knowledge. Ontology categorizes types of things. Heuristics uses practical problem solving, and genetic programming evolves solutions. Each branch addresses different types of challenges. Together, they provide a holistic framework for artificial intelligence research and development. The result is comprehensive cognitive computing capability. McCarthy's taxonomy reveals the field's breadth. Here's what you need to know for practical military operations. For practical military application, 4 branches deserve particular attention. Machine learning handles prediction from historical data. Threat assessment, predictive maintenance, and demand forecasting are military applications. Natural language processing covers text and speech problems. Translation, document analysis, and coalition communication require NLP. Computer vision interprets images and video for reconnaissance, targeting, and surveillance. Expert systems provide rule-based knowledge encoding for diagnostics, decision support, and equipment configuration. Look at this integration equation. ML plus NLP plus CV plus expert systems equals enhanced operational readiness and strategic advantage. Total learning systems are derived from combining these 4 branches appropriately. Here's something that surprises people. Let me emphasize expert systems because they're often overlooked in the era of deep learning hype. Rule-based systems encoding human expertise remain highly effective. They're less fashionable than deep learning, but often more appropriate for military applications. Expert systems provide transparent decision-making process versus black box neural networks. They're ideal for diagnostic tasks and decision support with clear logic chains. The military advantage is explainability. You can trace exactly why the system made a recommendation. Encoded human expertise is accessible to users without specialized knowledge. These systems are ideal for diagnostics, where accountability matters. Transparent expert systems show their reasoning. Explainable systems are critical for accountability in military decision-making. Here's where it gets interesting. Modern AI systems integrate multiple branches working together. Consider autonomous vehicles. They integrate multiple branches simultaneously. Computer vision provides environmental perception and obstacle detection. Machine learning handles prediction and behavior modeling. Planning algorithms manage route optimization and mission execution. Control systems execute real-time adjustments. Look at this integration timeline showing 4 phases. Environmental perception in the foundation phase. Behavior modeling in the prediction phase. Route optimization in the planning phase. And real-time adjustments in the execution phase. Understanding component branches enables better evaluation. No single branch solves all problems. Matching approach to task is critical for success. So how do you apply all of this? Here's your practical tool, the 3-question evaluation framework, a strategic approach for assessing AI claims and aligning solutions. Question 1. Where in nested hierarchy? Is it ML DL GenAI positioning? Question 2. What capability level claimed? Is it narrow versus AGI, realistic AI assessment? Question 3. Which functional branch aligns with problem? ML, NLP, CV, or expert systems? Positioning to functional fit. This framework prevents both over-skepticism and uncritical acceptance. It enables matching AI type to task requirements. Key statistics to display. 3 complementary AI classification systems taught since 1956 term artificial intelligence in use. 12 McCarthy's AI branches total, and 4 total learning objectives. The holistic AI assessment comes from the intersection of capability level assessment with nested hierarchy and functional branch alignment. Let me show you how this works in practice. Let's apply the framework to a legitimate claim. Our AI system uses advanced deep learning for predictive logistics. Positive assessment showing clear scope and alignment. Hierarchy position, deep learning for pattern recognition in supply data. Check. Capability level, explicitly narrow AI for logistics prediction only. Check. Functional branch, machine learning aligned with prediction problem. Check. Clear boundaries, it doesn't claim general intelligence or domain transfer. The assessment, legitimate application with realistic scope. ML aligned with prediction problem, narrow AI capability for prediction only, realistic scope and transparent application, explicitly for logistics prediction. This passes. This is a legitimate and realistic application. Now, watch what happens with vendor BS. Examine a problematic claim. Our AGI-powered system understands context like a human. Warning signs and deceptive patterns are everywhere. Vague hierarchy terminology without specific ML DL positioning. Red flag. Claims human-like understanding or AGI-level capabilities. Red flag. Unclear functional branch or claims universal problem-solving. Red flag. Pattern recognition system claiming common-sense reasoning ability. Red flag. Assessment. Multiple red flags indicate exaggeration or deception. The pattern here: exaggerated claims and human-like understanding, unclear hierarchy and unclear function, AGI claims despite no understanding, multiple red flags for universal capability and deceptive phrasing. This assessment failed. High risk of deception. Here's what's at stake. The framework prevents 2 critical errors: balancing skepticism and acceptance through framework evaluation. Error 1 to avoid: dismissing legitimate narrow AI applications due to over-skepticism. Rejecting legitimate narrow AI, missed deployment opportunities, and targeted application success all get lost. Error 2 to avoid: accepting inflated vendor claims without critical evaluation. Unsuccessful implementations, critical assessment failure, and vendor deception mitigation are the risks. Domain-specific training doesn't transfer well across unrelated tasks. Matching AI type to task is critical for successful employment. The framework provides consistent evaluation methodology for any AI claim. The evaluation framework creates balanced, consistent methodology at the intersection of over-skepticism and uncritical acceptance. Here's the bottom line. Summary. Your AI evaluation toolkit. Empower your decision-making with a structured, critical approach. You now have 3 classification systems for comprehensive evaluation capability. The nested hierarchy. AI contains ML, contains DL, contains GenAI, contains LLMs. Since 1956, the term artificial intelligence has been in use. Capability levels. All current ANI, 0 AGI ASI. This is current reality. Functional branches. 12 types of critical ML, NLP, CV, expert systems for specific applications. McCarthy's AI branches total 12. These combine into the 3-question framework you apply to every claim: hierarchy position, capability level, and functional branch alignment. In our next class, we'll explore the history of AI, understanding how we got from 1956's promises to today's capabilities, and why AI experienced multiple winters before the current boom. Class 3, The History of AI, coming next. Stay connected with AI for GIs. Visit our full course linked below. I'm Dr. Justin Webb. Thanks for joining me for AI for GIs.